because we've got, let's see how, okay, we're live. Yeah, we've got roughly 20 minutes. So those of you that are watching early, we've decided to go live early because you have two of the most opinionated GLAAC folks to listen to discuss what the universe is really like. I'm President Adrian Bradley and former Vice President, and I'll let you introduce what you do now, Liam. William Finn. What do you work on these days?
Well, I'm not a member of anything. I'm a member of the Ford Amateur Astronomy Club. I was a past president of the Ford Club. Right now, I'm just a nobody that gets involved in everything.
Well, that's how I ended up president. So
yeah,
don't feel bad. That's Andy, the knowledge that you have of the inner side of the physics side of astronomy and debunking some of the things that you hear when you look at media presentations is something that, you know, I think we both share a passion for telling a little more truth to those that are interested in astronomy rather than just following what the media says.
I wouldn't say there's no real honest to God truth in science, right?
Right.
Science is more of a path, a path from point A to point B.
Mm-hmm.
You start out with an idea, and then you take the idea from there to do some experimentation. And experimentation turns into, well, look, and this might actually work. So now it becomes a hypothesis, and then you take that hypothesis and you look into it even further, and you come up with an experiment to prove whether or not your hypothesis is correct. So you put some science behind it, and you try and prove it. And then if that is proven, or in your point of view, is you believe you have proven that it works, then you share that idea with everybody else in the science community, and even the people who totally disagree with you. You share all your results, all your details, all your experiments step by step in detail, exactly what you want, what you did. And then other people, even people who disagree with your point of view, will take your idea and your experiment that you documented, and they will try and repeat it. Now, if they don't, they'll say, nope, you're a fraud. It's not true. And if they do, they'll say, okay, I'm going to try to do it my own way and come up with my own idea of how to test this out. And they do, and if it comes up with the same results, then it's kind of accepted that you're on the right track. But there's no definitive in science, really. It's what's accepted at this moment because we don't know of a better way of doing it going forward. Yeah. 6 months' time, someone could come along and say, I've got a better way, and it's going to prove what you say is wrong. And that's fine. But they have to go through the same process, the same criticism of their work, and it's be publicly available before it can be accepted as the new natural, right? So,
right.
People have been trying for over 100 years to debunk Einstein's theory of relativity.
Yeah,
and they've all fallen flat in their face. They've never proven it wrong. They've proven there's nuances to it, but have never proven him wrong. So.
Yeah, I believe the only thing that was proven wrong was the constant that he tried to come up with. And I think Edwin Hubble's work was the only thing to show that maybe that constant couldn't be true.
Well, it's not that it's not true. It's that it's a variable, and a variable that does change. We're talking about the Hubble constant, right?
Yeah,
so
the Hubble constant.
That does change. And because it changes, it doesn't mean it was wrong. It means it was right for the knowledge at the time. And then later on, new knowledge has changed the view of how it's accepted and what is and is not accepted. And we've gathered more information, so now we can enhance what's there. He wasn't wrong.
Okay.
He had something that he thought was fixed was actually could vary.
Yeah, so those that are watching, I think we do have someone who's on a little early. We will be getting the H alpha viewing in about 15 short minutes, but we decided to start to have a chat about whatever comes to mind. And I like the direction it went in, because in today's world, you have a lot of folks that are saying the science tells us that this is right. For instance, the masking or unmasking. and we have a lot of folks that stand behind the science.
Well, that's a little different. The because when it comes to mask and all this kind of stuff, that's different because that's about transmission, and we know how that works. So there's definitives on that. You can't really argue that because it does help people, right? People might object to it. That's their opinion, and everyone's entitled to their own opinion. But does wearing a mask decrease the chances of spreading it if you're sick? Yes, because when you breathe out, your breath. Obviously, when you breathe out, you're breathing out air that can carry the virus and it can spread a distance, right? Mm-hmm. I don't want to get stuck in the COVID stuff, but when you're wearing a mask, it diffuses it, so it slows it down, so it doesn't travel as far. So someone who is 6 feet from you, there's less chance of it getting anywhere near them. And the same for you inhaling it, because a mask absorbs some of the water droplets that actually can carry it. So that's different. But other stuff, as we're saying, science is not 100%. It's a path. It's an investigation to get from point A to point B, and you go through the process, and then your process is critiqued by people who believe in you and people who do not believe in you. And if they find an alternative, then the alternative is accepted as if they can prove that their way is different. So it's supported, right? The only real proof that's out there is mathematics, right? Because there is something as proofs of mathematics.
Yeah, so Tim, you're joining us. We decided to start the stream a little bit because we, of course, we have our opinions and fact, and we decided why not have a discussion before Awni gets here to start the H-Alpha show. And I think we have a chat from Keaton V. Science is a thing that keeps us safe and sane, and I would agree with that. We're discussing science and how in today's world, a lot of folks will mention science when really they are mentioning opinion, but the true scientific process, whether it applies to astronomy or it applies to our world today with COVID, there is a true scientific process. It may not be 100% right, but that's okay, because science is about seeking what the truth is, the path of seeking what the truth is, and not necessarily, it's not an alternative to God as far as, God says this, well, science says this. What science truly says is, here's what we know, here's what we don't know, here's a theory on how we get there. And then you challenge that theory. And Liam, if I'm paraphrasing it, even if you don't believe that theory, you still challenge it.
That's a good question for Brother Guy, actually.
There's the one thing I would chime in with is there is a little bit of a difference because in science, so I'm careful to use the word theory because that's reserved for a special purpose in science. You start with a hypothesis, a wild guess. Now, it does have to be a guess that could possibly be tested. If I come up with a guess that there's no way to test, we don't get anywhere. So I have to come up with a guess for which I have the possibility of coming up with some kind of test that will help either confirm that I might be right. It doesn't mean I am right, but it means I might be right. Could also show that I'm probably wrong. And then we test those out, but we don't just test them. We document them. We make them available for other people who do not necessarily agree with us. And then they try to find faults in our ideas as well to see if they are coming up with ideas that we ourselves did not come up with. If no one is able to find the fault, and it always seems to work and the predictions that our guest makes seem to come true, then we promote that guess, that hypothesis, to the status of theory. But you don't have to take anybody's word for it because they're published, the data is published, the methods for testing were published, and everybody has the ability to review it critically to see if they can find a flaw themselves. So it's not like, well, you're just going to have to take my word for it. Lots of occasions throughout science where somebody came up with an idea that later turned out to be not necessarily wrong, but not yet complete. So I'll give you a quick example. I love to do this. Aristotle says things fall to the ground in proportion to how heavy they are. So if you drop the 1 pound cannonball and the 10 pound cannonball, the 10 pound cannonball will fall to the ground 10 times faster. And for the better part of 2,000 years, nobody bothers to check. So the first bothers to check. Turns out
Yeah, I love that.
Galileo checks. Galileo finds out it's wrong. He comes up with his idea of gravity, works pretty well. Newton comes along, finds a few nuances that he can tweak. His theory of gravity doesn't say that Galileo's idea was wrong, just says incomplete. There are a few things that he left out. Einstein comes along a few years later, discovers actually Newton's theory was a little bit incomplete, adds a few more things. So it's a process that we don't say we're right, that's it. Don't ever tell us any different. What we're saying is we leave open the possibility that we might learn something new in the future that tweaks our understanding of something. But today, this is the best explanation that we have given the evidence available to us.
Yeah.
Right. Again, the scientific process isn't just a way to say I'm right, you're wrong. It's a way to test whether you're right or whether you're wrong. And I guess I see a little bit of a humility in science in that you don't go in just saying this is absolutely true. And a lot of what I see on social media, I'm connected to that. I'll see a lot of folks saying this is what we should do because the science says. And I'm not so sure that's a proper use of science to prove a political point. I mean, that's kind of what I'm seeing in our world today.
It's not political.
I think it's being misused.
It's not political. Science is about the discovery. It's not about being political. It's about doing research to find out how stuff works and why it works the way it does. And in some cases, how can we overcome it? And that's what it's all about, figuring out how things, you survive surgery today that you wouldn't survive 100 years ago because science figured out how the body works and the nuances of that and can leverage that. The same for brain surgery. Like 100 years ago, if someone cut into your head, they were drilling a hole in your skull just to let fluids out. Today, they can go in and actually repair parts of the brain that they couldn't touch on, all because of science, because of investigation and learning. So it's all about it's all about learning, and it's all about discovery and advancing our abilities to do stuff in the world is what it's all around.
Correct. So, those that are watching, thank you for joining the meeting.
We have a few early birds.
Page. So, yep, we had a couple early birds. We had Keaton V
and Harmony
mentioned. I think it's who mentioned her comment earlier, or his Keaton V Hill, and then Harmony Smurf has joined us from Seven Ponds, I believe. Jeff is joining, and I am going to try and get Awni to join. He says he cannot join for some reasons, so
just resend him the link.
Yeah, and he should be joining soon. I see Jeff.
Hi guys.
Hey Jeff.
Hey Jeff.
Yeah.
Very sunny here.
Yeah,
that's
Where's
encouraging.
Speakers?
Yeah, Kate. I assumed you were a lady.
What's that?
No, someone's
we have
in on.
Yeah, we have
while we're on here.
I'm her. Okay.
I'm watching the Facebook chat as well.
Okay, yeah, and Caden, good comment on science. And it's one of the reasons we started early. I thought we were in pretty good conversation about it. Really, we hope through this presentation and through all the presentations at Astronomy on the Beach that we demonstrate, what we've learned through the real scientific process. And we've got Liam and Tim here, and Jeff, who goes through the scientific process every single day to try to figure out how to turn his telescope on, and he has to go through the same steps each and every time, and something still messes up.
The most important thing about when you're dealing with something electronic is never, when you turn it on, never let the magic smoke escape, because when the magic smoke escapes from something electronic, it doesn't work anymore.
Hey, Adrian, can you turn on live streaming?
I did. We're live now, and we've got a couple people watching us.
Oh, really?
Yep. So it's all going.
I'm just waiting for my lame ass.
Yeah, and we're also waiting for Awni, who seems to be having trouble connecting. So I sent him I think we all sent him the link to it. I'm certainly not prepared to show prominences.
Because I just
So-
pulled up the event and it's not getting any data.
I see it on Facebook. I'm watching it on YouTube. It's working.
Yeah, I'm
Yeah.
watching it.
Oh,
I'm
okay.
watching it.
Here,
There's Gordon.
live.
Yeah, Gordon's here. Welcome. We're all here, but apparently Awni's having some difficulty. We are live, but we're Awni's having difficulty joining. So I don't know if he's trying to join the wrong link or
I think he's avoided. I think he's scared of the questions going to come out of Gordon. So he,
Hey,
we're
oh,
ready for him.
because he
And
gave
so
Gordon a pretty
is,
good grilling last night. So
Yep.
you
So
guys
we're
are on
getting
Audi's channel. Never mind. I'm in the wrong place.
well, that would do it.
Yeah,
That would do it, wouldn't it?
yeah. So you're in the wrong place, but we're not. We can't be. 'cause
Bye.
Gordon,
Jeff, you're welcome to come to the wrong place anytime.
Yeah, I know, but you can't see my setup. I'm squinting trying to figure out where the
That's
screen
good.
is.
that's by design.
Good luck. I'll be
Thanks, Jeff.
around at the orange can place.
Oh,
Here,
Awni.
There's
Awni,
Awni.
you finally
There's Awni.
joined us. Welcome. You can unmute now. He will in a second.
Hello.
Hello, we can hear you.
Okay, fine.
So Awni, you thought yesterday was going to be fun? There's 5 of us here today.
Look at who you've got to help you ask all your questions. So you are.
I'm
So
loving
assistant.
it.
Where are you?
He's just sharing out his
Yeah, you're
screen.
just sharing your screen. All right.
Okay.
Oh,
Yep,
there's some
you
light
are
cloud out
live.
there.
Yeah. I
Yeah,
mean,
there are.
it was bad before, but it looks better now.
You can see the seeing conditions wobbling in and out.
It was like
Yeah.
that. Yeah. I mean, to be honest, yeah, I would agree because check this guy. Check
So,
this thing out.
While you're doing that, let's do a proper intro. So Awni is, which club are you with again? You're with WAS?
He's lowbrows.
Oh, the Lowbrow, forgive me.
And
Lowbrows.
Plymouth.
Yeah,
Yeah.
so Awni's with the Lowbrows and with the
Go ahead.
Plymouth Astrophotography, and he's big into doing solar observing and solar imaging. So Awni is actually going to walk us around the sun, look at some prominences and filaments in the sun, maybe if there's any sunspots out there, and we're going to discuss what we see. And please feel free to ask questions, and we may not know all the answers, but we know enough to get by most of the time. So
Yeah, we'll try. Why nothing is visible as now, and
just cloud, I can see it. Yeah.
clouds, but I can start with my setup and hold on, where is it? Hopefully by then the clouds will. I mean, give me a second. Oh, it's horrible. Oh well. Where is it? So technically what I used yesterday and today and since I bought this thing and with all the examples that I'll show is technically the Launch. It's a Launch 60 with just single stack, no double stack, and a 2.5 Barlow with a hold on. With an ASI 1600, I'm sorry, ASI 174 for the camera, mono. The uncooled version.
Well, I see you have a garden hose there for an external cooling system. I never thought to put a garden hose pouring water over my camera.
Well, some people actually do that, just an FYI. Glad you mentioned it. Usually when the sun is like early morning and or actually like evening time, and if it's pointing at a pavement or a garage or something that radiate heat, what they use is a water hose to cool it down so it minimize all the seeing effect from the hot pavement or the hot garage or whatever. So yeah, I've seen some used to do that.
I've seen people hose down the roofs of their houses in the evening in the summer They actually get out a hose and hose down the roof of their house to try and cool it, because what they want to observe is right over the roof.
Exactly.
So-
Just minimize that heat wave that is coming out of the whatever you're pointing above it.
So, Ani, importantly, you mentioned a term. You said a single stack, not a double stack. Can you tell us what that means to somebody who's not familiar with these types of telescopes?
So technically, the reason you use well, let me go back one step. The reason we use a solar scope to image the sun prominence, I would say, is because those scopes cuts the wavelength to up to 0.5 to 0.3 angstrom, which is 0.5 to 0.3 nanometer out of the whole spectrum. The reason we use double stack, though, is to get better contrast, meaning that wavelength, that 0.5 to 0.3, get reduced even further to say 0.2 to 0.1 angstrom, which is crazy if you think about it. And that basically, cuts more bandwidth and allow just teeny tiny bandwidth back to your telescope or your eyes in this case, and which makes which makes those granules are you can see more contrast with those granules, or even the what do you call it, the prominence. The prominence will look more, the background will look more dark, and the prominence will look more bright when you do double stack. I've never tried it before. Main reason is because it's way too expensive.
It is, yeah.
It's ridiculously expensive for just 0.1 or 0.2 nanometer extra. And I mean,
so for our viewers, unlike a normal telescope where you're trying to collect as much light as you possibly can, you're trying to avoid collecting too much light. You're trying to get it down to just one particular wavelength of light.
Otherwise, if you do so, but that's basically what the white filter does. If you do so, you'll end up with something like that, just bright orange disc, nothing, no texture, nothing in it.
And or a melted telescope.
True.
Or both.
Melted binder. We had a situation where in the other chat, the gentleman forgot to take his finder off. He got lucky.
Yeah, and happy you mentioned that, Adrian. Guys, please don't look at the sun directly or even through a telescope, like a non-modified or non-solar telescope, or even if it's a normal telescope with a undefined or like manufacturer-wise, you don't know who manufactured that solar filter. Please don't do that. As we discussed yesterday, you can go blind permanently. So, go to an astro club. There are people that know they know what they're doing, and you can easily look through a solar scope and enjoy the sun and the prominence and any texture that is visible through that scope. But don't just look at the sun and I bought this on eBay, it should work. Please don't. Anyway, going back to that setup, as you can see here is so with that scope, the way it works is you can shift that wavelength, that visible wavelength that the scope allow to the left and right using a pressure chamber, which is this thing, using a pressure knob. Now, the problem with that is you have to go out, change that, rotate that knob, go back inside, see if there is anything shows up technically. But what I did myself is I 3D printed a mechanism to control this knob, and the reason it's like small gear and big gear, and this thing is strong. You have to use your muscle in order to rotate it, because technically it's just a valve that pressurizes that tube and depressurize it to shift that 0.5 angstrom to the left and right for the across the spectrum. The other thing that 3D printed part does is I can use it to autofocus as well. So technically, I don't have to go outside. I can do everything through that, through the computer. And this is for the pressure, and this is for the focusing. The whole thing is, and that's basically an Arduino board. It's a DIY thing. You can download it through from the internet. Everything is mounted on a EQ mount, an Ioptron CM25 mount, and then all the gizmos, all the equipment here are connected to a USB hub. That's a power distribution board that I did, and then it connects to a long cable that goes inside the house. And this is a 10-meter cable. You can get a 15 and 20-meter cable. It's a USB 3 cable, so you need a fast cable to do some live viewing or even fast frame rate video, capture fast frame rate video. And this is just a battery, 12-volt battery that operate everything else.
So I was just going to comment, I do have the double stack version of that telescope. You can optionally remove one of the etalons, the tuning etalons. What you gain is a little more contrast on the surface of the sun, so you can see detail there a little more easily, but the downside is the prominences that are coming out of the edge of the sun around the limb, those become much fainter and more difficult to see. So, so it's not all good news to add it, and some astrophotographers that do solar imaging will literally remove one of the etalons to take all their photos of the prominences and then put the etalon in to get the image of the sun and then shuffle the two together later.
And just to add to Tim, the price, I got this scope used for $1,400. This double stack that Tim was talking about is just another piece that screws in front of it, and that piece can go all the way to $1,200. So it's as much as the telescope itself. It's just another piece that you screw in. And for my taste, I didn't see any, I didn't see any use of it to spend all this money, to spend all this extra money.
And if the telescope is just a slightly larger diameter, the cost of the etalon is exponentially more expensive.
Exactly.
Yeah.
Sounds a lot like photography.
True.
Where the prices are for minor changes are costly. So those of you watching the stream, have your money ready if you want to get equipment, or do what Awni did and look for some deals. Used equipment taken care of well will work very well for you. So you don't have to go new.
Cloudy Night is your favorite place to go.
One of the most important things to get when you're going to take up this hobby is the name of a good bankruptcy lawyer.
No, he's kidding.
Gordon, do you have that image I sent you earlier on an email?
Yeah, I'm sorry I didn't get to it yet, but I was also going to add, as Adrian was saying, you can find great deals on Cloudy Nights Classified and on Astromart. But the other good thing is, on the other side, sometimes you buy things and you say, well, I don't really need this anymore. And so there's a market out there for you to recoup some of your investment. So selling is pretty active on this. So.
Yeah, you can use Cloudy Nights for used Astro equipment as well as Astromart. Both of them are good places to get used in clean equipment. So far, I've seen most people on it are honest. Everything you see here is used through Cloudy Night, so I'm happy with it. And one more thing about solar scopes. Oh, don't point the solar scope directly. Don't aim the solar scope at the sun with the help of your eyes. Don't look at the sun. Oh, am I on the sun? No, yes, no, don't do that. There are some mechanism that most solar scopes come with, and And with this guy, it's like a finder scope, but for, oh, come on. There you go. It's like a finder scope that goes on top of the main telescope, and it's technically just two plates. One has a hole, and the other one has like an acrylic. So when the when the scope is perfectly aligned, the sun's beam that goes through that hole, when it hits that acrylic, that centerpiece, you're pretty good. You're pretty on it center-wise or aiming-wise. But yeah, don't use your eyes. It's a very precious thing. You don't want to lose it. Trust me.
You can have an ordinary telescope and then get something called a white light filter. It goes on the front of the telescope. It's typically more important that it go on the front of the telescope rather than the back, because that keeps most of the sun's energy from going through the tube and making things inside very hot. But you can get these things commercially made, and they're not actually all that expensive, but you don't have a finder to help you line it to the sun, and you can't use the optical finder that comes with the scope because you'll melt it. I have a colleague in the club who accidentally did that, and what we tell people to do is get the telescope so that visually you think it's near the sun by looking at the shadow on the ground. So you try and get the shadow to look like a circle, and then you're pretty close.
And as well as that, you can, like if you do have a telescope and you want to put a white light filter on it, like we just described, not a HA, like they're a special purchase, you can actually buy the material and make them yourself as well. It is possible to make them yourselves. I make mine for my own scopes, but you have to buy the right material from a reputable company. I used a Bader film. And you can actually build your own filters to go over the front of your telescope if you want to. But and it's a cheaper way of doing it than going out paying $70 or $80 for a filter from a company. You can buy the material and you can make it yourself. So there are options out there to make it cheaper on you to do so.
I will point out though that if you're going with a white light filter, you will not see the prominences off the end of the sun.
Correct.
Oh, yeah.
The white light filter is great for seeing sunspots and
that's it.
And the filaments and things on the surface, but you will not see any of the prominences coming off the side.
Yeah, you won't see any texture on the sun. You won't see any prominence. It's mainly to look at the dark spots, and it's good for solar eclipse, I guess.
Well, the difference is the white light filter blocks all wavelengths of light, but it blocks 99.999% of them, right? So there's only a tiny fraction of the normal light from the sun comes through, whereas a solar HA scope, like what Awni is showing, is it only allows a tiny fraction of all of the wavelengths of light that come from the sun. It only allows a tiny amount of that light to come through. It's not all the different colors of light. There's only one specific color called hydrogen alpha, which is the wavelength of light of excited hydrogen gas. And that's all it allows in. Everything else is blocked by that telescope. So that's why we can see prominences with the HA scope and filaments and so on, and we can't with a white light.
The good news, though, is you don't have to buy something like that to look at the sun. If you have, say, a 6 inches or 5 inches telescope, refractor in this case, with current technologies, you can technically buy an eyepiece that works as a solar scope. So it has some electronics in it that basically eliminate all the wavelength, and it passes only again 0.3 angstrom to your camera or to your eyepiece.
Daystar makes those.
Most people get amazing results with those. And you don't have to buy a new telescope. You can use your existing telescope to change this to a solar one. So technology is a good thing, It's as expensive as this guy, but you don't, it's up to you.
Actually, since we're talking about hydrogen alpha, explain to everybody why we use a hydrogen alpha filter telescope on the sun. Why specifically hydrogen alpha? Other than it being the excited hydrogen gas, why do we use that?
I guess because the sun is made mainly from hydrogen, 70% of hydrogen and 30% helium.
Yeah.
And when it get excited, that's basically what's happening on the sun. It's just nuclear reactions over and over and over again. And the main emission that is coming out is near hydrogen alpha, and that's why we use hydrogen alpha to image the sun. With that said, you can still use different wavelength to
Like calcium K and so on. There's
calcium
other
K
wavelengths
and stuff like
Yeah.
that, and to image the sun. But with that said, I guess hydrogen alpha is the most the images that comes out of from hydrogen alpha filters and scopes are the most beautiful, I guess.
Yeah, I have a HA scope of my own, a smaller one than yours, but I love my HA scope. It's but yeah, because the sun is mostly is made up of plasma, which is superheated gas, right? And if you superheat any gas, you get a plasma. But the superheated plasma on the sun is mostly hydrogen gas. It's over 70%, and because of that, the outer surface, and when you see prominences or filaments, which hopefully we'll see some, and we can explain the difference to you. But when you superheat, the magnetism of the sun gets twisted and knotted up. For an easy explanation, it gets twisted and knotted up, and it comes up above the surface and creates these loops above the surface of the sun. On the outer edge of the sun, on the limb of the sun, we call them a prominence on the outer edge of the sun, and those loops, as they move, because magnetism moves, they pull up super hot plasma with them, and as they do that creates the shapes. He's going to show some images
of talking. Yeah, like talking about that.
Yeah.
So we imaged the sun yesterday, and that was on the edge of the sun, and it was just that's basically a prominence.
Yes.
So it's technically when the plasma get ejected, and because of the sun's gravity, the sun is like, you're not going anywhere, so it just goes back to the surface, and that's and when you see that at the edge, that's basically what's a prominence, what is called a prominence. The other one, which is a flare.
A filament.
There you go.
Filament.
It's a filament, not a flare.
A filament, I'm sorry. It's technically a prominence, but it's not at the edge. You can see it at the surface, and like the dark spot here. And that's technically a prominence, but it tries to escape from this white part or the hot part, and it couldn't escape, and it just came back to the surface. And I guess this one is a filament as well. But
so
that was yesterday.
Fun fact.
It was a beautiful day, beautiful sky. I'm sorry, what?
I was going to say a fun fact I have for you. I'll switch my background to Thomas Edison's laboratory. So Thomas Edison visited McMath-Hulbert Observatory, where they had the first hydrogen alpha telescope here in Michigan, actually the first in the world. And he was invited to take a look through the telescope, and he saw these features on the surface of the sun. And he asked the astronomers, what were those? And they said, those are called filaments. And he said, great idea. I'm going to use that for the filament, and that was the part in the middle of the light bulb. And so the reason that thing in the middle of your light bulb is called a filament is because of those features on the sun. True story.
I'm filing that one in a way for to demonstrate that my trivia knowledge is better than my friends. So thank you for helping me with that. Where the filament came from. Although it may be on Google, just that said, knowing that alone is a good thing. Carry on.
But the nice thing with the prominence or filament or anything, it changes by the minute. That's why I love the sun. that's why I love imaging the sun, because every time you look at it or image it or, you know, observe it, it's a different thing. It's the granule changes like by minutes. Filaments, for example, that was captures the filament here, the 13, that was captured at 3:13 yesterday, and almost 2 hours later, it looks like it changed to something like that. And if you compare it, I mean, it's not even the same one. It's a totally different one. Everything here disappeared. That thing became like different shape. And one thing about imaging the sun, because it changes so fast, all you have to do is just capture a snapshot every 30 seconds for the next hour or so, and you can create a time lapse out of it, which is, you know, I mean, which is amazing if you look at it, to be honest. I have a few examples here.
Yeah, I was going to ask if you had a time lapse to show, because apparently the clouds have kind of clouded over the sun.
Yeah, I know. So,
welcome to Michigan.
An example of a time lapse. Yeah, I know. This is an example of a single 30-second exposure. And you see, like, there is something beautiful. You can work with it and come up with a single image. But if you capture one every 30 seconds for an hour or so, and then stack and process the whole thing, look what's happening. It changes like crazy, and you can't even see it again. You know, it's a one-time thing. It doesn't repeat itself next day or even next year or whatever. You know, whatever you got, it's permanent. There's another example over here, which is technically my favorite. That's another 30-second exposure. Oh yeah, this one. The seeing was perfect at that day. I can see all the details, but again, you can process that, get a single image, good, you know, good for you. But same thing, 30-second every, a video every 30 seconds, stack that, look at that. And the reason why it's my favorite, it's because, there you go, wait, there you go. That's because it's my favorite, because who said the sun doesn't spread love? There you go, here's a heart shape. So it's a beautiful thing when you capture time lapses and share it on social media. It just tells people what you can do when you image the sun. The other thing with solar imaging is someone asked me, why is it black and white? The reason it's black and white because, oh well, the sun isn't standing there. The reason it's black and white is it's more sensitive to use a monochrome camera, which is a black and white camera. And believe it or not, it's so easy to add colors to it later on. Here's another example.
Well, and the telescope only allows one color through anyway. So if you had a full color camera, the green and blue pixels would not pick up any light whatsoever, just the red ones.
Exactly. Everything's going to be super red, and you need sensitivity. You need that high resolution and sensitivity when imaging the sun. I mean, technically, you need that when imaging anything, even planets and deep sky objects. But speaking of colors, for example, that's a monochrome image, and you can add colors to it later on, and it's going to look like that. I mean, that's just beautiful, to be honest.
There's a slight lag. There you go.
There we go.
Right about that. That's nice.
So let's talk a little bit of fun facts about the sun.
Before you say that, I was just going to say, if you remove the camera because you can put an eyepiece on that telescope and look
Oh,
through
yes.
it. You
Oh, yes.
do actually see an orange-red looking sun. It looks like that to your eyeball. So I just wanted to say that if this were a live event this year, you would be able to look through one of these telescopes on the beach and you would actually see the sun looking like that.
And that's thanks, Tim, for that. The reason B is if I Google hydrogen alpha emission, it's actually within the red emission. Hopefully there is something. There you go.
Now we're waiting for your screen to catch up.
Up there.
That's the hydrogen alpha.
Lag.
Yeah, give it a minute.
There you go.
There you go. Here's the hydrogen alpha, and it's within the red spectrum. And that's why if you put an eyepiece and look through, you'll see a red sun, which is kind of convenient because that's what you expect to look to see.
Later on tonight, Liam and I will actually be showing that off. So
Yeah, we'll be talking about how we can analyze the light of coming from a star, like the spectra you're showing here. And we'll be talking about how we use that, the spectra from stars and other things in space, to figure out what it's made from.
What it's made from, what direction it's going, if it has a planet, if the planet has life on it, the gas pressure on it, the mass of it, the magnetism of it. It is just a shocking amount of information hiding in the light.
In a tiny little dot of light, you can learn a lot about what's in space. So we use that, and we're going to talk about how we use that to investigate space. Without having to go out there, we can figure out what stuff's made from and how it works.
Go ahead and plug the time for that, because for those that are
it's 8:30 this evening. It's for 1 hour, 8:30 to 9:30 this evening, and it'll be a great event. As I said, Tim and I are going to be on there talking about the science of using spectroscopy is the term used, and we'll be going through a presentation showing examples of how we can use spectroscopy to identify what elements are out there. So we can use that to figure out how stuff is made, what it's made from, how it moves, how heavy it is, and there's a lot of information you can gather just by looking at light. And that's how scientists know what's out in space today and how stuff works out there.
Excellent. So you won't want to, if you are intensely interested in stars, what they're made of.
Not just stars, this covers gas clouds and everything. We use it for everything. It can be used for a lot of things.
You don't want to miss that presentation.
If you want to nerd out, come hang with us at 8:30 tonight.
Probably the best way to put it. So yeah, it'll be fun, I'm sure. So So what are we looking at right now? Is this a picture that's already been taken, or is there anything live?
Yeah, so this is yesterday's recording of the sun. And I guess you guys don't want to see the prominence here, but you can definitely see I would say a dark spot or sunspot here. But the reason I brought this is you might, sun is like, textured. Why does it have a dark areas and light areas, like lighten areas? And the reason B is, think of it as a lava, boiling lava, except it's way much hotter than the lava. If my memory serves me well, lava could boil up to 2,000 Fahrenheit, and the sun can go all the way to 10,000 Fahrenheit. So it's way more hotter. But again,
in the middle, the core of the sun is about 15. The core of the sun is about 15 million degrees. Yeah. Inside the core of the sun, it's 15 million degrees. So yeah, it's not somewhere you want to go on vacation. It's a little bit toasty in there. And as you move out, it cools down to the outer layers. But then when you leave the outer layers and into what's called a corona, which is like the atmosphere of the sun, the glowing part around the outer edge, that actually gets hotter again because, and right now we have ideas about why, but we actually have a spacecraft, the Parker Solar Probe, orbiting the sun right now, trying to investigate that, to try and understand why the corona is actually hotter and actually this stuff increases and even accelerates in speed compared to other stuff, and they're close to the surface. So it's science going on right now.
I will have to stop this and come back to it because eventually the cloud just cleared up a little bit, and hopefully it stays here like that for some time.
I dropped a link in if you want to look at the
You know,
National Solar Observatory when we cloud out, but
the reason I wanted to show this is that was from yesterday, and that's now. And look how much it changed. It's not even the same potential. Oh, there you go. Beautiful. It's not even the same potential dark spot anymore or sunspot anymore. It's just a difference. The structure changed, the filament changed, everything changed. And another factor which is beautiful about the sun is if I zoom out here, there you go, and bring up that original image that I got. Hopefully that's this one. Nope, it's the other one. There you go. And just try to put it next to each other. Within 24 hours, plus minus, the sun rotated from this part, that spot rotated from this spot to that spot. Now, I don't have the exact knowledge on how fast the sun rotates, but that just tells you, gives you a visual effect, not effect, visual fact on, the sun, a visual fact of the sun's rotation, which is, again, it's something, it's another cool thing to.
It's roughly once a month.
About a month. Yeah, it's about 30 days. And because it's not solid, however, it turns out it rotates angularly around the equator faster than it does around the poles. So it actually kind of twists a little bit as it rotates.
Yeah.
By the way,
That's
around,
part of
it's
the
around
reason why
10.
you get solar flares and things, because as that twisting is occurring, it's twisting up the magnetic field lines, and when they get all tangled up, that's when they can start bursting out of the surface.
Yeah.
So, Awni, I don't know if you can nudge around the limb for a while and noodle around that area. There looks to be a pretty nice prominence up around 1030 position. Of course, I don't know the rotation of your camera. If 1030 for your screen is 1030 for the sun's north.
Yeah, I can definitely do that.
Move up and see what's up there.
For those who are wondering,
there's one there.
In order to see the prominence, I have to pump up the exposure from 6 nanometer to 6 millimeters, 6 millisecond to 30 millisecond. That will overexpose the sun's surface, but it will show up. All the prominence will definitely show up. So hopefully.
I think you need to go up. Yeah,
I need to go up. Yeah. Let's see if we can find it. No, I don't see it there.
Go down. Yeah, I think that was it down in the bottom left-hand corner.
Does your telescope flip the image or in any way?
It would, because it goes through a prism. It goes through it's a right angle point on the end. Right angle.
Yeah, so that must have been prominence then.
Yeah, I linked you a real-time image from the National Solar Observatory, that page in the chat.
There is something.
And
yeah, there is something small there.
There's one here.
Yeah, the one in the south, the one if you go down, it was actually better.
There's another one here. You know what? I could pump up the exposure even more. There you go. There's a tiny one here. We'll definitely
Yeah, so if you look in your
find
chat,
it. Just give it some time.
if you look in your chat, there's a link, and that's where I found it.
Oh, there's definitely something here.
Yeah, the
Okay,
best one is on the one over
chat.
to your left. Maybe if you tune the echelon, we might be able to bring out more detail a little bit.
Tim,
Yeah,
I
the
went
one.
ahead and posted your link again, and I just explained those who want to see a real-time image of how the sun looks any day or time after this presentation, they could cut and paste that
Okay, so
and
we're
take a look.
talking about southeast. Yep, it's. I think I know where it is. It's that one. Oops, the other way. Yeah, I think you're talking about this one.
Yeah, maybe if you focus a little bit more, and maybe I see if you can tune the echelon a little bit.
It's not the focus, I'm afraid. It's the cloud.
Oh, there's a haze over. Okay.
Yeah, you can see the clouds kind of rolling through, and that's
Yeah,
I
kinda-
was
see how
watching the
much-
cloud come in.
Yeah, you see how much
Oh,
cloud?
wow.
I mean, at 50
Oh, yeah.
milliseconds, the sun and the background should be overexposed, but it's still dark, meaning yeah, we got
Yeah, you can see the clouds running through there.
plenty of clouds that covers the sun. But with that said, I think you're talking about this one. Because I imaged it yesterday and it's still visible. There you go, this one.
Yeah, it could be that. It's just changed shape, yeah.
Yeah, we'll keep an eye on it once it clears out. I see some small patch coming in. We'll definitely be able to see it by then.
So some fun facts first of all about the sun that people may not know. If you weren't on yesterday, you may have covered this. So the sun, in its physical size, in its diameter, okay, the Earth is 109 times smaller than the diameter of the sun. But if you put the Earth inside the sun, you can put 1.3 million Earths inside the sun, and still have room to swish the Earths around inside the sun. They still have room inside there. So size-wise, it's huge.
There you go. Here's an example
Nice.
of a sun scaled next to a prominence.
Yeah, and there is an event later on this evening that talks about size and scale as well of the solar system. That'd be very interesting, especially for any of our younger viewers. It'd be really cool because you're like when you're younger, you're learning this stuff in school. So it's really interesting to find out how to see physically a size comparison. So yeah, we are really, really small, and we're not the biggest planet out there. Like Jupiter is 11 times larger than us in diameter, right? So
and here's one thing.
If you stack 11 Earth one on top of the other, it'd be the same diameter as Jupiter.
And here's one thing interesting about Jupiter is it rotates in 10 hours while Earth rotates in 24 hours, even though it's way bigger than Earth. It's just crazy.
Yeah. Yeah, a lot of the gas giants have a very fast rotation, which is why they have really strong surface winds in their atmosphere as well, because of their rotational period is really so fast. But there's stars out there that rotate fast too. Our sun is almost perfectly round, but there's other stars out there that they rotate so fast. Like if you're on a merry-go-round and in a playground and it's spinning, and you feel that you're being pulled to the outside, right? You get pulled outwards if you're out near the edge. So there's stars out there that spin so fast, and because their rotation is so fast, that they're no longer round. They're actually shaped like an egg. Their equator is actually stretched out because of the rotation speed is so fast. So
to give you a relative, kind of relative size of what we're talking about. Let's say this is it's even
it's smaller.
Smaller, should be smaller. Well, I can make it smaller. Anyway, the sun. I have to shrink this even lower. which I can't. But just imagine how big the sun is compared with the Earth, which is like a tiny pickle next to it. It's crazy.
Yeah, but the sun is almost perfectly round, which is kind of unusual anywhere. Even planets are not perfectly round. They're always a little. Planets are what's called. Most things in space are what's called an oblate spheroid.
Oh,
Like if you get a basketball and sit on top of it, and you squash a little bit, so it's squashed north to south, but wider in the width. That's what most stars and planets are like. But our sun is almost perfectly round, which is. And oh, nice! There's your prominence from yesterday.
Yeah,
There's a
here's
live
the
view of it
prominence.
now.
Look at that.
It's very
And-
different.
We got us a prominence. So all of you that are arguing whether the Earth is flat or round, you're both wrong. It's
Yes,
an
it's
oblate
kind of the
spheroid.
mixture of both. It's an oblate spheroid.
Yes. So there you go. It's
And here's
it's a mixture of both. It's not one or the
uh,
other. See, there's harmony in truth. So
uh-huh.
with that preaching, I'm just gonna go back on mute.
And here's a comparison of
carry
the
on.
same prominence. Yeah, from yesterday
so-
and today. Look at that.
I have a question then, Liam, Tim, or any on the panel. How long does a prominence typically last on the sun?
Oh, that's like saying how long is a piece of string.
Yeah.
That can be anywhere from 5 minutes to 20 or 30 days. We've seen prominences and dark spots, like cold spots in the sun, last for days, weeks even. But the vast majority of them are anywhere between 5 minutes or 10 minutes. Some of them will show up and then they'll fall apart almost immediately. Others, like this one, has been there for the last 2 days, and it looks like it's decaying. So it may be gone by the end of today or even tomorrow. But they can last weeks, or they could last. Like I've seen some form and fall apart and rain back down into the surface in the space of 15 minutes. Live, watching it actually happening, I could actually see parts of it falling back down into the surface. So that's
I was at Kensington for one of the hearing days event.
Glad you mentioned it.
This was several years ago, back when we used to do the solar observing on Heron days at Kensington Metro Park, and one of the tragedies of astronomy is that when you're younger, your eyes work so much better. They're so much more sensitive, and then you get older and you start to really get an interest in this stuff, and that's when you find out your eyes don't work so well anymore. So there's this young man, and he's looking through my solar telescope, and I'm showing him the prominence on the edge of the sun out on the limb, and he's all excited about it. And then, a little while later, he's coming back and he says, "Hey, what's all that red stuff off in space to the right?" And I'm looking through my telescope, thinking he must not know what he's looking at, and I don't see anything. And he's like, "No, it's there. And other kids are looking at it. They see it. It turns out it was a coronal mass ejection, and the prominence had erupted, detached from the sun, and it was shooting out into space. And this young man could see it, and I was so frustrated. I did eventually see just traces of it. For him, it was pretty easy to see. For me, it was a struggle to see. So sometimes those prominences actually do detach and fire off to the side.
Oh yeah, and I have an example of that as well. But before we get there, here's what Liam is saying. That was less than an hour activity. And just check that prominence that goes up here, goes all the way out, and then comes back. Hopefully it's smooth enough. But that's just less than an hour activity. And see how much things just erupted within the surface. Nothing escaped, I think.
Yeah. So let's talk about what a prominence is, right? Gordon mentioned about, and Tim mentioned about the equator around the sun, because the sun has a north and south pole like Earth does, right? And around the equator, it spins faster. So what a prominence is, if you can imagine magnetism going from the north to the south, like a magnet, like we have on Earth, and it's actually like they're joined like this, okay, going from north to south. But with the center moving faster, it kind of pulls those magnetic lines around, and they get knotted and pulled around and get twisted. And when they get twisted, Some of them bulge above the surface of the sun. And when they bulge above the surface of the sun, they put up the super hot plasma with them into that loop of magnetism. Now, that's what we call a filament or a prominence. Now, filament and prominence are the same thing. It's just that one's on the edge of the sun, so we can see its shape. The other's on the surface of the sun, so it looks like a cloud. Like we showed a few just there. Or he's showing one right now. But when that lines of magnetism get really twisted and knotted up, eventually there's going to get enough energy in there that they're actually going to snap and break. Just like a ball of rubber bands. If you keep wrapping the bands tighter and tighter and tighter, they're eventually going to break. And when they break, the plasma and charged particles that are in that loop of magnetism, that gets twisted, gets released and thrown off into space. That's what we call a solar flare. When that breaking of the magnetism lines happens, and that material is cast into space. And that's actually the reason why we have northern lights, because those emissions from there and solar wind, which is a different topic, but they actually interact with the magnetic field of Earth, and the charged particles gets pulled down into the north and south poles, and it excites the gas in our upper atmosphere, and that exciting the gas makes the gases in our upper atmosphere glow, which is why we have northern lights and southern lights.
Speaking of, we'll get back to the flare part, but speaking of aurora, we're getting some activity this week, aurora activity, and most probably is because of that.
Looking for something that could possibly be the source of our aurora activity that's coming. How long typically between, and this is a question for myself and viewers that may be interested, how long typically from the time a solar flare breaks off of the sun till we see the aurora here on Earth?
It's a few days. I think it's typically around 3 days or something like that. It depends on the output energy of the flare when it happens, but we can see it at any time because solar wind can send charged particles our way as well. But a flare sends a large amount of them. But you must remember, it's sending them from one small area of the sun, but as it goes out, it spreads out, right? So it's as well as that, because the sun is rotating, it's not spreading out in one direction. It's spreading out, but also rotating. So it goes out from the sun, but it goes out in an arc, trailing away from the sun, in an arc away from it. So if you go to the Soho website, see some images of some animations of it, and you will actually see like little arcs coming out of the sun. And that's the path, because the sun, as the material is ejected, it spreads and creates a little trail behind as the sun rotates. So the sun is still pulling some of the particles with it. But it takes about 3 days, sometimes up to 5. Depends on the energy of the output, I believe. From I've been a good place to get good information is spaceweather.com. There's a great place for watching that.
I'm sorry, go ahead. But speaking of aurora, I'm guessing the reason for an active aurora within this week is because of this guy. And this guy is not even, it's coming towards us as we speak, maybe in a couple of days or so. But just imagine, again, anything that is coming out of this activity here, it's getting spread. But by the time it's facing us, if anything happens by then, we will definitely see some beautiful activities aurora-wise.
If you're in the north, if you're further north, it's rare that we see it this far south in Michigan. But if you're far north, like Upper Peninsula and so on, or if you're anywhere like really in Canada or so on, those are the better areas because it depends on the intensity of the outflow will dictate how far south. It's called a KP index, and the intensity of the eruption and the amount of material that's out there will dictate how far south the aurora will come. So we need to hit about KP versus KP7.
Who knows? It might we might see something this week.
Yeah, it might. But we generally need to have a KP7 for it to reach it down this far south. KP5 would be like the UP and Canada.
So, but here's the interesting rub now. If a KP7 or 8 event did occur, should we be worried about what may happen to our electronics after we see that?
No, not at that level, no, because our atmosphere will protect most of it. The main thing we need to worry about would be satellites if for a big event like that. And even there is another really big event called a Carrington event. Now they happen rarely, and if they do, it's rarely that they're not directed at us. They do happen, but they're often facing away from us. If a Carrington event does hit us, it can fry all electronics. So no internet, no watching YouTube, no watching our live streams.
There have been some historical bad ones, and they can fry the weather grid, destroy generators and substations to the point that power outages over wide areas happen. And we've become so dependent on the energy grid in order to survive, unlike people who would have lived, hundreds and hundreds of years ago, that if that happened during, say, the wintertime, could potentially freeze to death. Also, these events can induce enough power into the power lines that they can cause things to spontaneously catch on fire. And at the Carrington event in the 1800s, the telegraph stations were spontaneously catching on fire.
Yeah, so they're rare. And when they do happen, luckily they're not because the sun is so large and it's a sphere, it's round, right? So most of them, we've seen some happen in recent time, but they weren't aimed at us. So they were aimed at the sun. They're on the other side of the sun, or the part of the sun that had already turned away from us, and there was a huge CME, or coronal mass ejection, or solar flare, and it was away from us. So some of it affected us a little bit. We got really nice, beautiful auroras out of it, but because it wasn't directed at Earth, our systems were saved. But if it was directed at Earth, it could affect satellites, communications. Your power lines can start glowing and sparking, and transformers will blow up. Your generators will blow power units and power stations, and it'll take the whole electrical system out. If they do, but they're fairly rare when they do happen.
Yeah,
but they do
and
happen.
we should mention too that with the sun being at solar minimum, it would be even rarer for such a huge event to happen.
Correct. Yeah, the sun goes through 11-year cycles, and it's just starting to wake up out of its minimum and starting heading towards its maximum now. But that'll be in a couple of years' time. But it's starting to wake up. It's going into a new solar cycle, and as it goes into that cycle, it starts getting more and more activity, which means we see more prominences, more sunspots, and so on appearing in the sun. So it'll be more interesting for solar observing. But it does lead to a maximum, and then after that, it starts dying down again to go into a minimum. So it's a cyclical cycle. It goes through every 11 years, approximately 11, 13 years.
Yeah, I would imagine around that 10th or 11th year is when our solar observatories would start looking to make sure that such a huge mass ejection isn't going to happen. If they'll look for signs of it to make sure we're not going to face one of those head on.
But it's always been watched.
The time to look for it.
Yeah, we have the Soho Observatory is permanent, is full time. All it does is monitor the sun. So even when it's at minimum, the Soho is actually watching the sun. Soho is the Solar Dynamics Observatory. It's a spacecraft monitoring the sun 24/7.
And
so don't be afraid of the event, but we are watching for it. For the most part, go north if you want to see aurora.
Yeah.
I think during that Carrington event, aurora could be seen as far south as the tropics.
I heard Florida
on the equator.
Yeah, I heard Florida down by Florida. They actually saw the aurora down there at that time.
So
we've had events that have gone down to Atlanta within the last 10, 15 years.
Yeah.
We had aurora at the astronomy at the beach about 10 years ago.
We had it less. We had one. Didn't we have one at Great Lake Stargaze? Was it 4 years ago? The year David Levy was there.
Yeah.
We had one when we were up at the Great Lakes Stargates with David Lee when David Levy was presenting there.
And so we can see them here on occasion, and not as you get up by Hudson Bay, you're going to see them more frequently, obviously, but they're not totally unreasonable down here.
I've seen them in Sweden, and I've seen in northern Sweden that they were really beautiful up there.
If you visit spaceweather.com, they have a section of the page that will give you the aurora predictions and show the aurora oval over the globe so that you can see if there's a chance of an aurora overhead near you.
All right, so Awni, we've followed this Aurora talk. We pretty much jumped your session. We need to give it back to you.
Well,
So you can
okay with that because
show us what you're presenting.
That's one of my lucky shots or captures, I would say, of a time lapse. And I don't know if you can see it or not, but on the lower right corner, that when it's at, let me just pause it. There you go. There is actually something happening here, like a, there you go. See that? That just came out of the sun, and it kind of affected that prominence, and it just erupted the whole thing, like 3, 2, 1. Look at that. Poof. And that's probably escaped the sun's gravity. I don't know. But
yeah, that looks like it might have been
that's one.
Yeah.
If I play it quick, I don't know how good the streaming is gonna be, but you can definitely see like a hiccup. It's like shoot, and it's gone.
Yeah, that looks like it was a flare. Yeah, there was an ejection there.
Yeah. Yeah, and so imagine if this is facing Earth or even close to Earth, that would definitely be an aurora activity up in the north and south, I guess. But again, I don't need a young guy to see it. I can just pump up the exposure electronically and be able to see all the activities here. That's basically what Liam was talking about. Like if the sun, if it happened to have a flare, escapes the sun, and it's pointing relatively close to us, Earth, I mean, we'll definitely see something. We'll definitely see some aurora activity.
Yeah, I actually was looking about. I just checked. Our aurora activity our potential aurora activity is because of solar wind right now. There's actually a coronal hole in the northern part of the sun, and it's emitting a lot of solar wind. So, and that's what's carrying the charged particles to us right now. So that's why our activity is up.
Don't take my word for it, but I presume it's this one getting closer to us. I might be wrong.
Well, yeah, it could be, but there is a coronal hole there as well, creating a big one going right up to the north of the sun that's creating solar wind, emitting a lot of solar wind. So, but it's kind of, yeah, I love hydrogen alpha. Is the sun being covered by the clouds?
Because I captured this at the end of yesterday's session, and the nice thing about solar telescopes. Oh, by the way, can you guys see this? I'm pointing my mouse on it. Hold on, let me back up a little bit and maybe slow down. There you go. I'll try to slow my frame rate to say 5 frames per second. Hopefully it works. There you go. Does anyone see that?
Oh yeah.
Now, I've seen it before, and I got three things that I can say that I can explain what it is. One, it could be a space junk or debris. Two, it could be a flying seeds. And three, it could be just crazy birds flying way up in the sky that, you know, happen to be in between the telescope and the sun.
Must be
But that's
Icarus.
just one thing nice to look at.
You know the
Could
story
be,
of Icarus?
you know, one time I was showing a video of the solar, of the sun to a friend of mine in Texas, and he was like, "Yeah, that's whatever the bird is." I'm like, "Are you sure?" I'm like, "Yo, those crazy, those crazy birds can fly way high in the sky. You can barely see them." We're on social media. We can't say more.
Yeah, but it reminds you of the story of Icarus. You know that story?
No.
Oh, it's an old Greek mythological story of
humor us with this stuff.
I can't remember what his father's name was, but they decided to build wings. They wanted to fly like birds, so they made wings, but they actually joined the feathers together on the frame using wax. And so they actually took flight, and they were able to fly. And his dad warned him not to fly too high to the sun, but he didn't listen to his father, so he flew higher and higher. And what happened was the sun melted the wax, and all the feathers fell off, and he plunged to his death. So, but it reminds you of that because you saw something that looked like it was flying close to the sun, which is similar to that story.
Not a happily ever after story.
It's not a happy ending story. No, it's one of the few in Greek mythological stories that is not happy, but it is a story.
Yeah.
So.
And the other thing about solar telescopes, the nice thing about it is you can definitely see it. It's like a 3D effect at the edge of the sun, where the hot and the granules. You can definitely see some 3D effect here that shows like the granule is coming out and then sinking in. And again, you can't see that with a white filter. It's only a hydrogen alpha filter, and once you tweak that atolon to get that perfect texture, you will definitely see lots of details, whether it's at the center of the sun, at the edge, or even prominence-wise. I highly recommend for someone who if you got the money to get a solar scope, because it's a different thing every time you look through. I see that the clouds are just killing us.
Yeah, they're starting to move in. I was just checking my sky camera, and there's more and more cloud moving in. But that's forecast. It's supposed to get somewhat cloudy around 4 o'clock or 4:30. So.
Well, and meanwhile, I can explain a little bit of image processing. Like how I got that time lapse and how do you capture solar scopes if anyone is interested. I presume.
Yeah.
Some are. Chat. Go back soon. Okay, so let's do one of the images that we captured yesterday, and now we can do the prominence here, or even actually no. I would prefer to do that would be a great example here because you got surface texture as well as the prominence. So
before we get too far off those other comments, and we're talking about solar scopes, and I agree with you, Awni, but you don't have to go buy a lunch. If you're just getting started and want to get interested, is a Coronado PST, a personal solar scope. They're not going to do the kind of stuff Awni's doing with them, but if you want to do visual observing of the sun, you know, they're in the $700 range instead of, so they're a lot more affordable than at the low end, and they are hydrogen alpha scopes.
And again, one more thing about solar, I mean, any astro equipment in general, don't just Google something and, you know, like reviews and stuff like that. Find yourself an astronomy club close to you. Go there, ask around, see what's going on. People will love to help you at the club, to point you to the right direction. And I didn't start that way. I kind of did Googling and reading, and this is good, this is bad, maybe this, maybe that. But I was kind of lucky, but not everyone would be lucky like myself. You would probably buy something that all the reviews say, oh, it's beautiful, and then you end up with junk, technically. So ask around. You will be surprised on how many people would love to help you and point you to the right direction to buy the proper equipment that will give you the good price. I mean, good results for the price.
Can I just add one thing? For everyone who's watching, if you would like to click on the like button, the thumbs up like button below us, please click on the thumbs up and the subscribe button so we can, it helps promote these recordings and these videos out on YouTube. So click on the thumbs up and click on the subscribe button. So anytime we publish new events out on these YouTube channels, you'll actually be notified of the new recordings. So you can go check them out whenever they become available.
Sweet deal. So yeah, like Gordon said, there are cheaper solutions. If you already have a telescope and you're not willing to buy another telescope, there are eyepieces that you buy, solar eyepieces. There are many options that you can get same results that I'm getting with a cheaper price, you know, without breaking your wallet, technically. So going back to image processing, yep, so cloudy. Anyway, the way you do it is you don't capture one image, you know, like a snapshot. No, you don't, because there are many factors in it. Mainly, it's the seeing, and to show you what I mean here is. Here's an example. Oh no, that's a very good example. That's a very bad example. There, if I maximize it, see how how the image is wobbling, you know, it's just and the reason being, it's the atmosphere. You're looking through Earth atmosphere, and that atmosphere might be a good atmosphere, might be a turbulence atmosphere. It's more like looking through candle, or what is it? Looking at hot pavement. You know, looking at something at the end of the pavement road, everything will be wobbling because of the heat wave. And that's technically what our atmosphere is. It has different layers, and each layer has a different temperature. And when you look through it, because of that temperature difference, the image is wobbling. And if the sun or planet or anything that you look through is closer to the horizon, technically you're looking through more atmosphere, so it's more wobbly.
It's like looking through, looking at a penny at the bottom of a pond.
Back to that, there you go. So the way we do it is we don't take one image, we take multiple images as a video. So we take a 1,000 frame video, and each frame is like, for example, with my settings here, it's 6 milliseconds. At the end, you'll end up with one video that it's wobbly, and which is good, because out of that 1,000 frame, you're probably going to end up with 100 frame, which has the perfect scene. So going back to this image, there you go. The way we do it is we use stacking softwares. There are tons of it, but personally speaking, I use AutoStacker, which is free. There's nothing wrong with free.
Best price.
Yeah. And I'll just walk through the process that I'm doing. So what you do is you open that video that you captured, and if I could find it. Nope, it's on the C drive. There you go. And we are looking at surface. And what it does is now is asking you for what do you call it? The object, or the object that the software will use to stack all the images at, or check what the best, sharpest image of that object. So you just point that rectangle at it. So what I'm doing is I'm pointing at the prominence as well as some of the surface texture or details. And all you do is just analyze. And what the software does, it goes through all the 1,000 frames, and then it tries to find which frames has the best details, sharpen-wise, like best sharp frames out of the 1,000 frame. So in my case, wow, that's pretty good. In my case, almost more than 75% of the images are sharp, which is surprising. And you don't need to stack all 80, what is it? All 75% of it. You can stack just 25% of it, which is 250 frames in this case. And surprisingly, it will still give you some beautiful image at the end. So in this case, what I'm going to do is I'm just going to put some anchor points that the software will use to align all the 25% of those images together and get me that sharp image. And in this case, I'll just there you go. There is a automatic button here that always automatically look at the it puts those points for me. I don't have to go and click all those points, fill the image with all these points. The software can do that for me. I'm gonna stack only 20% of those images, and that's it. Stack. Now it depends on how fast your computer is. It might take minutes. It might take seconds. It might crash.
Might take hours.
It might take hours. It might crash. Who knows? And so now technically, what it's doing, it's trying to choose the best frames. It's trying to align those frames according to the stacking points that I chose or the software chose, and now it's stacking all these 20% frames. And there you go, done. Now, if you go back to the same folder, it technically created one image, one stacked image out of the 20% of the main video. So if I open that, there you go. That's technically how you stack any, how you stack solar, planetary, lunar images. Same concept can be applied on all of those. Now, it looks good. It looks decent. It's kind of acceptable. You can go with it, leave it be, or you can do a little bit image processing. You can use Photoshop, you can use Lightroom, you can use whatever software that pleases you, it's easy for you to use. My personal poison is PixInsight. It's a paid software. It's not cheap, but trust me when I say that, it's worth every penny. And in my case, I have a preset project. Hopefully, bear with me, please. There you go. It's inside. And I think it cost like $300 or $300+. But that's just one-time payment. It's not so far. It's just one-time payment. Hopefully, it's not a subscription. It won't change into subscription like most softwares does, like Photoshop, for example. And what I'm doing here is I already had a project that I saved for planetary, lunar, and solar that I use those processes to enhance my, sharpen and process my images. And in our case, here's the stacked image that I got from that I got from AutoStacker. Let me just pump up. There you go. And all I have to do are, mainly I use two processes to enhance my images. And they're basically, let me put it this way, they're basically called wavelets. There are tons of softwares for free. You can get them for free. If you Google, if you go to AutoStacker website and you go to resources, there are tons of resources in there to teach you how to enhance the stacked image and what software you can get, what are the free ones, what are the paid ones. It's a very good resource. So technically what I'm doing is just sharpening and playing with wavelets to get the best image out of it. Let me try different settings pre-settings that I have. Oh, that's too much. Let's go back. Oh, way too much. And you can always tweak your settings. Oh, that's decent, kind of. They're just different sharpening settings that I could apply. Just that's overdone. There you go. And that's better. And let's repeat the sharpening. Yeah. That's just a quick work. But compared with the previous one, it's definitely a huge difference. Let me put it next to each other. I'm not giving a tutorial here, but I'm just giving you an example of how you can process your images to get a sharp image at the end. So that's the original one that the stacked software came up with, and that's the sharpened one. I might have overdone it, probably, but you can get an idea of what and how to stack and process or sharpen your images at the end. Now
I have a question.
Sure.
Since we don't have any in chat right now, how much time on average would you spend processing in this way to bring out more detail one of your solar images?
I would say an hour or less.
That's not bad.
Yeah, because again, if I don't have those pre-configured procedures, I might take longer because I have to, find the procedure, tweak it, and then reapply it every time. Probably apply it for a dozen times till I'm pleased with the process. And sometimes if the scene is pretty good, I don't even have to apply anything. I'll just keep it as it is. So that's technically how you get a single image. Now, adding color, you can definitely do it with PixInsight, but I choose to do it in Photoshop. And you can just Google YouTube on how to add color to solar images. It's pretty straightforward by just playing with with curves. So that's technically how you process your solar images. And that can be applied, again, on planets, on lunar, on deep sky objects, all of them.
The difference is on solar, planetary, and lunar, you're taking video, like you did. And on deep sky objects, you're taking longer exposures. And actually, we have at 10 o'clock tonight, we have Gordon Hansen was doing an overview of how you process images because he was supposed to do live observing like we did last night, but the skies are not going to be clear, it looks like. So instead of that, we're going to do something that does not require a telescope because of the clouds. And we're going to look at, last night we did some rudimentary stacking using live stacking, but tonight we're actually going to go more into the process of stacking deep sky objects like a galaxy to create the beautiful images that you often see published online and so on.
I'm just wondering if the sun's still there.
Thank you for that advertisement.
I just thought since he was showing us processing here, it'd be a good follow-on if someone likes to see how it's done with planetary and so on. It'd be nice to see how it goes on into the deep sky stuff, which we have later. It looks like you're in the tree again.
Yeah, so sun is kind of cleared out. I mean, cloud-wise, but now it's thanks to my beloved neighbor tree is just blocking the sun. So
we offered chainsaws to you yesterday. You should have taken us up on that.
Next time.
Tell you what, we should do what Tim Campbell says. You can go over, cut the tree down, and then we'll use wood glue and put it back up again at the end of the night.
You're muted, Tim.
I said it should work. It's wood glue.
Yeah, it's wood glue. It should work fine. Yeah.
The other alternative is that the sun is emitting just trillions upon trillions of neutrinos, and that neighbor's tree is completely transparent to neutrinos.
Now we just need a way of detecting and imaging neutrinos.
Unfortunately, your camera is also transparent to neutrinos, and your eyeball is transparent to neutrinos.
The planet is transparent to neutrinos.
Yeah, it's gonna pass.
A slab of solid lead 4 light years thick is transparent to neutrinos.
Yeah, it's gonna pass.
Yeah, it will.
Hey, Awni, back to your processing. You really caught me off guard here a little bit. I was surprised to see you go in and do the sharpening in PixInsight.
Oh yeah.
Well, I've always done it with Registack. You know, I've used Auto Stackered for the stacking and then gone into Registack. So
yes.
We're going to have a longer conversation here.
Oh, definitely.
Or you get buried down inside your little process icon because.
Well, here's the thing: Registack does wavelets, and there is a process in PixInsight that does wavelets as well.
Yeah.
And so you already paid for the software. It's better to use it.
Well, I agree with that, but Registack is free too. So.
Registack is good if you want a budget and if you're starting out, but.
So folks on the call, welcome to the Plymouth Astronomy Club. You're getting a sneak preview of what we talk about every month when we process our images. Carry on.
Well, we'll have to talk a week from Tuesday about it because I'm really interested in what's buried down inside your process icon. So.
Sure thing. My pleasure. Well, while the sun escapes the tree, I could discuss how to do time lapses. Like my favorite solar heart prominence here. So this is the same process. Each one of those frames, like a 30-second video, at the end it becomes just one image, and a time lapse is technically taking those images, create a video out of it in a timely manner, and then it just plays everything quickly like a movie. There is a problem though. depends on how good your alignment and how good is your how good is the what do you call it? Wind wise, guiding wise. Oh wait, never mind. With solar you don't do guiding. I mean technically you can, but it's a long subject. The whole thing will shake, and as you can see in this video, the edge is actually wobbling, and that's just a small part of it. The whole thing just shakes up and down. And there's nothing you can do. That's just a part of the solar or even planetary or lunar imaging. Your mount is not perfect. It's gonna shift. So
Well, that's why you
so
do
I already
video.
explained how to get a single image. To get the whole, but to get all these images that you captured across every 30 seconds, let me put it this way, together and aligned, it's a different technique. Now there are many softwares that does the alignment for you, but my personal preference, and I already got the all the stacked images of that time lapse, and these are, and again, each one of this is a stack. Each one of those images is a stack of 1,000 or a 700 frame video, and it's the same process. I did use AutoStacker to get each one of those images, which I just explained previously. But to get them all in video, you think, oh, I already got the images. Let me just put them in a video and see how it looks. Except, let me show you what happens. To do so, I use a software called PIP. It's also free. And when you add all these images together and create a video, it would look like that. Where is it? It's on the desktop. On the solar time lapse. There you go. I'm not gonna do any image stabilization. Nothing. There are tons of options in there. Again, you can use that with planetary, lunar, or solar. That's the beauty about it. Okay, let's create an SVR file and process. Okay, then cropping. Fair enough. Here you crop it. Okay. Nope. Hold on. Just a second. Let's do that. Okay. So I'm setting the crop factor here. There you go.
We need to leave shortly, some of us, because we have another event starting at the top of the hour.
Okay.
So in about, just give you a heads up that if we drop off in the next 5 minutes or so, you have you know why we're not abandoning you.
No worries.
Yeah.
So
I'm here for the duration. I'm your original moderator and host, but Liam, Gordon, and Tim do an excellent job. And provide more science than I could provide. All I can do is cheerlead and tell you go, Awni, go. So I appreciate them coming in and offering very excellent color commentary, especially on a day like today where it clouded in and out.
My pleasure.
A lot of good information to share with those that are viewing.
My pleasure. So going back, I won't take much time. I mean, I'm just gonna explain quick. what I did with Pip is I cropped the images because each image is has a different resolution, and just stacked them together without any alignment, without anything. But look how the video looks like. Horrible, like shaky everywhere.
It's an earthquake movie.
I know. With that said, it's not a problem. It's a quick fix.
Probably technically accurate if you were there trying to watch that from that vantage point on the sun. That's probably what would be happening to you.
True. Now you can use Pip itself can do what do you call it? You can use it to align your images better. So solar, it has a preset here, so you can use that to put the prominence in between, and technically just yeah, it looks good. Update that. There you go. And do some processing. So Pip is technically a good software to align your images. Okay.
So I'd like to download that now. Where do I? Is it P? How is it spelled, and where do I find it?
PIPP.
Okay.
Yeah, post the link in chat so people can have access to it.
The planetary image preprocessor. The guy that wrote it said that he wrote it a lot of years ago, and he had a very slow computer. And one of the things that he was interested in is, I think he said he was using his DSLR, and the frames were way too big. And he said, but if the planets were really small, and he said, if I could just cut out all the blackness of space to make my big frames small frames, my computer could process it faster. And that was sort of his original inspiration for writing the utility, but it's lived on and it's used for all kinds of things.
Oh yeah, for being a free software, I think it's a very strong software. And again, I mean, you can use it to align your images. You can use it to create a different type of videos, GIF file, AVI file, SCR file, whatever. So after doing some alignment process here, the final image looks decent, except some of those frames, the software thinks it doesn't belong to, so it just rejects them. I would say it's a 50-50 thing that might work, it might not. You can tweak those settings and it will definitely work better. But going back again to my personal preferences, and for me it works 100% every time, is I go to Auto Stacker again and technically just load up those stacked images that I use Auto Stacker to get them. There you go. There. And it's actually a surface texture, and that's basically what I need to align, which is the prominence. Do align. I need to. It's just another step that you have to crop every image, which is an easy fix. Give me a second here.
So if you take all of your images at the exact same frame or exact same dimension and everything else, and you gather those, would this be a step that you could then skip because everything should be aligned?
Yes, but from experience, it's always gonna be wobbly. So no, yeah, I mean, you'll definitely need some sort of stabilization software, and from my experience, you can use the same software that you use to stack every video to align all those images. like I'm gonna explain here.
Okay, Ani, we need to drop because we have to go for our next event. So
Okay.
this has been fun as always, and we might see you online later on.
Will do.
All right.
Thank you very much.
You.
Take care,
All
guys.
right.
Thank you, Lynn,
Okay.
Tim and Gordon, if you're
No.
also heading out.
No, I'm going to hang around. I'm not involved in their next one, so
He-
I'm staying with Awni.
They didn't.
He doesn't
They
want
didn't
to
allow
learn
you to
about.
join the cool kids. We see what's going on.
Gordon doesn't want to learn about the rest of the universe. He already knows. So.
He already imaged He already imaged the rest of the universe. He knows about it already. He's got files from it from last night. He's already got it all.
Good deal.
All
All
right.
right.
All right,
Thank you,
guys.
Thank you.
Take care.
Thanks, guys. Thanks for all the help and pleasure. So the reason AutoStacker didn't accept those files because each file has a different resolution. So what I'm doing here is just making sure all those files have the same resolution. Again, pip can't do that. It can. What I'm doing here is I'm just cropping each one of those files to a different size, and the output, instead of a video, I need to. The output needs to be an image file again, which is a TIFF file in this case, and just start the process. So what it's doing is it's creating another folder that contain the same files, but they're cropped. Okay, so far so good. Now let's go back to AutoStacker and load those cropped images into it, which I presume it's here. Just choose images. There you go. And open. Now, like I said before, what you need is to make sure the prominence is going to stay. You're trying to stabilize the prominence or align this prominence all together. You just put your alignment box on it and analyze. Now, before what we did is we stacked all these images together, but no, we're not going to do that. We're just going to create another set of images, but they're all going to be aligned. And it's just going to take time to align all the frames together. And 3, 2, 1, done.
So is AutoStacker also a free download, or is that something?
Oh yes,
that you
it's a free
invest?
software again.
AutoStacker, I'll go find the link for that.
Now you don't have to choose which frames to stack. You don't have to click stack. All you have to do is untick. So now it's going to play the best frames in the beginning and then the worst frames at the end. You don't want that because you want that perfect sequence. So just disable the sequence like that and then play. Look at that. It did a great job every time. And you can see how the frames are shifting, like left, right, up, down, left, right. And that's because AutoStacker aligned the prominence and then just simply cropped, you can technically crop the end. There is a crop factor. There you go. Yeah, instead of expand, you can choose crop. And there you go. It technically just crop the images away from the edges. So any edge, just, it can't kind of cut it for you. Now, if you like the outcome, just stop playing and export. You need to export all of them into a different folder. So let's create another folder here. New folder, done, and save. Let's just put it in name.
If our viewers haven't got any idea by now, one of the things that's at a premium on our computers is big hard drives.
Oh, yes.
You can see how many images he's creating.
I have a 3 terabyte hard drive hanging off of mine because even though I'm new to all of the imaging, I just know I need that space as I move forward with this particular part of the hobby. So get yourself a nice big drive to hang all your images in, and that investment can run anywhere from say 100 to 150 bucks. I'm sure there are drives for a lot cheaper than that. Definitely go for that.
Again, I would suggest go to Costco and get a 8 terabyte hard drive for 120 bucks.
Even nicer.
Yeah.
I have I just came across a 3 terabyte drive to sell, and I'll sell it to you for 50 bucks so I can go get the 8 terabyte hard drive from Costco. Just kidding. Carry on.
Anyway, so what AutoStacker did is I exported all the aligned frames out of it. And now what I'll do is I'll go back again to pip, load those aligned images together. I'll just remove everything. Go and load those images, which I presume, there you go. And I don't want to do any processing or alignment or anything. I just want to output a video from it. And you just do processing and export. Now, I might went too fast. It takes a little bit of experience. It's really not that complicated. It just once or twice, once you play with it, it becomes like a muscle memory, and the results are just mesmerizing. So now after I created a video out of those stacked aligned images, it's going to look like that. And I mean, come on. There you go. Now, of course, you can add color to each one before you stack it or create the video. Of course, you can add the earth, scale the earth next to it before you create the video. It's, you know, your imagination is the limit. But at the end, you will end up with a beautiful image or video, time-lapse video that, you know, you can technically show off to your friends and family. That's how you create the time-lapse. Easy said than done, though.
Yeah, I've got a bunch of images that I took and just to play around with live stacking that I'm going to have to use this process for. Prior to taking some comet photos back in July, I decided to try to do a bit of a time lapse. So I took some photos using one of my the imaging mount in time lapse mode. So I'll get to play around with this. I downloaded pip and auto stacker just to so I could play around with those things sometime and start getting familiar with them.
Yeah, they're not that, again, the nice thing about them, they're free. They're not very complicated to use, and the results are just overwhelming. So luckily the sun escaped the tree, and we are able to see some of the details. Of course, it's getting lower, meaning it's getting closer, so to speak. I have to refocus again, and knowing from experience, if I go out, I get better results. Nope, let's go back in. There you go, looks decent. And let's, oh, did I close the focus? Oh, I didn't.
We have a comment from Dave New. Read some information, a C-class solar flare, solar activities picking up sunspot AR2773, and I'm not sure where that is. It erupted this morning during the early hours of September 26th, producing a C1 class solar flare. NASA Solar Dynamics Observatory recorded the extreme ultraviolet flash.
Well,
so I guess this was an ultraviolet light and not the HA,
not hydrogen alpha.
Not the hydrogen alpha. So it's, yeah, and that's one thing. I know we talked a lot about most of the sun's wavelength is coming out in hydrogen, hydrogen alpha, but it does emit other wavelengths such as ultraviolet and other views of the sun show up with those other wavelengths.
I won't be surprised if it's this guy.
Yeah, that it's aimed at us, so, or not directly at us, but it's facing us. So yeah, that's probably the one. And I think you have an image of it.
And here's the live view
the live image of it right there.
Yeah. I'll play with the pressure knob here. Hopefully I'll get a different result. Oh, there you go.
That's where the, so Dave knew this area on the screen right now is probably where that C-class solar flare came from. This activity that we're seeing here.
So Adrian, do you see how the dark parts just became more dark? That's because I changed the pressure inside that pressure tube, and it went from everything is too light to being able to see more texture.
Yeah. No, I see that.
But yeah, it's actually I can drop the exposure.
Oh, yeah, it's coming out of cloud.
There you go. You can drop the exposure now, and yeah, you can definitely see lots of textures here. Speaking of which, I'm kind of liking that. So let's capture a video that I can process later on. So what I'll do is I'll just capture an SCR file. 6 and capture. There you go. That's how easy you capture video. And whether it's lunar or solar or planetary, using fire capture, and I presume there is another software called SharpCap.
Yeah.
One more time.
On my other machine.
One more time. Fire capture is totally free. SharpCap is free up to a limit.
Yeah. Well, very good. We're about 10 minutes out before we go ahead and in the stream, and that depends. We have Harmony Smurf again saw the C-class solar flare info on space weather as well, so she's following along just like the rest of us. We see clouds starting to invade the sun once again, but we want to thank those of you that are still watching in. Debbie Smith, we saw you. She, of course, reminds me of John Coslin, who used to come to Astronomy on the Beach each year with that big 24-inch scope. Sadly, John is no longer with us, but the 24-inch scope now belongs to Diane Hall and Jonathan Cade of the Warren Astronomy Club, and they're carrying on with it. Thank you again, Awni. I would say continue on maybe 10 more minutes or so before I shut down. If there's anything else at all you'd like to share,
sure.
Let's go ahead and do it. And you just took the video of this developing sunspot here, so
yeah,
go ahead and finish with that.
I mean, it's not a spot; it's a potential sunspot, but it's definitely something different on the sun surface that might be a sunspot. Who knows? And let me maximize that. There you go. So for those who are unaware what a sunspot is, it's technically a cold cold spot on the sun that all the plasma is just getting sunk in. But because of that, it kind of creates a hole that where all the magnetism can escape, which creates the all the turbulence on the sun surface, and which creates the the flare on the flare and it creates all the flare that escapes from the sun's gravity that again that might hit the earth and create the aurora effect. We haven't had the sunspot for a while now. Oh, did you just see that, Adrian? There you go. See that? I'm gonna play.
Yeah, it's a subtle move. So
Slow.
describe
You
what
can
you
see
just
it.
saw
Now again,
in your video.
look at that. Upper right corner.
Yeah.
Something is just zipping across the sun. Now again, I can't tell what it is. It could be space debris, it could be a bird, or it could be a flying seed. Just crazy.
Yeah, that's an interesting. That's made for a very interesting video. You would have to highlight it in a circle so that people wouldn't miss it. Now I don't know that because the clouds are flowing in this direction, so that's definitely something else.
Yeah. And
I wouldn't be surprised if it was a bird
one
flying
thing
through.
about I won't be
Small bird that's out of focus.
surprised. One last thing about solar imaging before we roll this out or end the streaming is wrap up is you can also do solar imaging while the International Space Station transit across it, across the solar disk. And the nice thing with that is you don't need a solar scope. You can use a white filter and just aim at the sun while the ISS fly across it, and you will definitely see all the panels, all the solar panels, even the body of the ISS. But beware, that thing is super fast. You just go, whoop, it takes less than a second to fly across the sun from one edge to another. So that's another field of photography that you can have fun with during the day instead of the night, like most astrophotography do.
Yeah, I think you've captured some ISS transit photos, haven't you, lately? Within the last few months, I thought.
Yes, I did, but not across the sun. I'm still waiting. I don't like to travel. I don't want to travel, but I'm just waiting for the ISS to fly across the sun from my backyard, and I would definitely be interested to image that. With that said, if you are willing to travel and you don't mind carrying all the equipment with you, you can definitely travel to a spot where the transit is going to happen and just wait for it, image it, and then go back home. And
I tried that with the my first solar eclipse. I went down to Tennessee to image that. So the same process, but then with the solar eclipse. And unfortunately, I did not have a DSLR camera at the time. My imaging abilities were not there at all. It was an iPhone on top of the telescope. That's my solar image, but at least I have that and a lot of great memories of having traveled down with my kids to watch it. So
sweet deal. Yeah, with ISS transit, you will definitely need some fast frame rate. because that thing is super fast. And again, it passes across the sun from one edge to another in less than a second. So I would recommend. I'm sorry. What?
I'm thinking my mirrorless camera at 1/4000th of a second, if I can use that shutter speed and adjust the other settings.
Yes.
In order to capture any part of it.
Yeah, anything that is, I would say, one to 2 millisecond, which is 1/1000 or 1/2000 of the shutter speed, should be enough. Or in case of frame rate, anything close to 120 frame per second, or even 100 frame per second, you would definitely be able to capture some of the ISS details across the sun. Because again, the sun is too bright. You don't need long exposure, but you will definitely need fast shutter speed, because that thing is just too fast. That's the reason why you need a fast camera.
Yeah. Well, then again,
yeah,
too.
I'm afraid the sun is almost gone. Nothing.
Yeah. Would it be would I use a solar filter or just fire directly at the sun with that fast shutter speed?
Oh, please, with a solar filter.
That's what I thought.
Always a solar filter. Unless if you're willing to lose your camera or fry up that sensor, it's really up to you.
I think I've taken one unguided, really quick shot of the sun without a filter, and I've taken an unguarded shot of the sun when we had nature smoke filter. Those pictures, the one without the filter, and probably won't be doing it again. It didn't fry out the sensor because I just used that to shoot at bald eagles earlier today, so it works. But like you said, it's something I don't recommend at all. I had the solar filter for the I have a solar filter on it, and I also have I have the image without the solar filter, but there was so much smoke in the air that I was able to get a shot of it without frying out the sensor, because most of the sun's light, it was low to the ground, and the sun's light was just the smoke, and how low the sun was just conspired to make it, it was not the bright disk it usually is around that time. So that was, and I definitely don't wish for there to be a lot of smoke just so that you can shoot at the sun without a filter. That's how bad the smoke had gotten those couple of weeks ago, that I was able to pull off an unfiltered shot of the sun. The shutter speed I used for that was 1/4000th of a second. And I think I had a f-stop of 11.
If you're trying to capture the ISS across, though, it's more than just shutter speed, it's frame rate. Because as Awni said, it's going to be gone in a second, and you got to capture it. So you really need video. I don't have a mirrorless camera, so I don't know what kind of frame rate you can get out of it. But I
have to look. It does have a video option. Yeah. So if I were to mount it on a tripod and start the video with that solar filter, that's probably what I have to do. And then I have to see what kind of frame rate it's capable of. Because I don't know. I have the Sony A6000, which is a little newer mirrorless camera than the Canon 6D that I have.
Because what Gordon is saying is because you can't just take a snapshot. No, it won't work. You'll need a video, and a very fast frame rate video to be able to, capture the transit across the sun. And not many cameras can do that efficiently. Let me put it this way. Not many DSLR cameras can do that efficiently.
Yeah, the frame
like Awni is using today on the sun, because he can get the frame rate. It's a relatively small chip compared to the DSLR. So the amount of data that it's got to push down the wire to the storage device is less. So you can get that kind of frame rate out of it.
That makes sense. Yeah, I've got an APS-C filter, and I do know the frame rate on it. If you just take snapshots, it's like 11 per second.
Yeah,
which is a far
That's
cry
not
from
enough.
the
That's not enough.
100
We're talking
to
about
120 per second.
Yeah, we're talking
you
about
say
way more than that. Like, for example, where I can show you, if my exposure is say 1 millisecond, which is good enough for ISS, my frame rate um, um, explodes to 130 frame per second, which is I'm trying to show it in the with the mouse here. So that's technically what you need to capture the sun.
that's a combination of not only what the camera can do, but it's already knows what kind of throughput you've got down to your storage device.
All right.
Oh, yeah.
Yeah, so that would take some experimentation, putting a filter on and getting a video of the sun, just to see what sort of and then looking it up to see what sort of frame rate that my camera has. So more homework for me. So I think we're about ready to go ahead and wrap up the video. There are still 10 viewers, but to those 10 viewers, as you can see, the sun's totally clouded out now.
Yeah.
We've got cloudy weather. We want to thank those of you that stayed for the entire presentation or were here for any part of it. Thank you for joining us. We're going to go ahead and cut off the stream now. Thank you all for being here and enjoy the rest of virtual astronomy at the beach.
Yeah, there you go. So it's really bad, as you can see in a second.